Could fat be the brain's new villain? For decades, amyloid beta plaques and tau tangles have held that notorious role in Alzheimer's disease, hogging the spotlight as the agents responsible for memory loss and cognitive decline. But recent research suggests there's another character lurking in the shadows: tiny lipid droplets inside microglia, the brain's immune cells. And while they may not have been on the radar for so long, these fat droplets are proving themselves to be more than mere side players. They're actively contributing to dysfunction, and scientists are starting to treat them as formidable, yet ultimately addressable, villains. Microglia are the brain's frontline defenders, the tireless janitors and personal trainers keeping neurons safe and synapses clean. Normally, they patrol the neural landscape, absorbing and breaking down harmful proteins, clearing debris, and regulating inflammation. They run on a fuel mix that includes free fatty acids, turning energy into action. But in Alzheimer's, the plot thickens. Microglia start hoarding fat, turning these normally nimble and efficient cells into sluggish, overstuffed versions of themselves. The lipid droplets act like mischievous little antagonists, weighing down microglia and preventing them from doing what they do best. In other words, the very cells designed to protect the brain are slowed by their new, villainous roommates. The enzyme DGAT2 plays a starring role in this drama. Think of it as a greedy sidekick, constantly supplying microglia with more lipid droplets than they can handle. Normally, DGAT2 is useful, helping the cell store fat safely for later energy use. But when DGAT2 lingers too long, it turns microglia into hoarders, filling them up until they can't move efficiently and leaving plaques unchecked. The fat droplets, in this sense, are little troublemakers, harmless in moderation, but disruptive in excess. They jam up the cell's machinery and reduce the clearance of amyloid beta by as much as 40%. It's as if the janitors of the brain have been tied down by sticky candy wrappers while the mess piles higher around them. Here's the encouraging part: this villainy isn't permanent. Researchers have discovered that by blocking DGAT2 or promoting its breakdown, microglia can shed their excess fat, restore their mobility, and resume clearing plaques efficiently. Suddenly, the previously overburdened cells spring back into action, reasserting control over the brain's environment and restoring balance. The lipid droplets may have been causing trouble, but they're not undefeatable. They can be managed, cleared, or neutralized, allowing the microglia to reclaim their role as defenders of neural health. This discovery is game-changing because it reframes Alzheimer's not as a hopeless battle against inevitable plaque accumulation, but as a problem of metabolic imbalance that can be corrected. The fat droplets are villains, yes, but they're villains that can be stopped. Microglia aren't broken. They've just been overwhelmed. Once we understand the pathways that lead to lipid overload, we can intervene, giving the brain's immune system the chance to fight back and protect neurons. Moreover, the implications extend beyond Alzheimer's. Lipid droplet accumulation has been observed in normal aging and in other neurodegenerative conditions, suggesting that addressing these metabolic villains could help maintain cognitive health across the lifespan. By keeping microglia metabolically fit and free from lipid overload, the brain can maintain its natural defenses, reducing inflammation, preventing plaque buildup, and preserving memory and clarity well into old age. There's also a relatable, human element to this story. The fat droplets aren't inherently evil, they're only problematic when unchecked, just like anyone who indulges too much and loses focus on their responsibilities. The good news is that, unlike many traditional villains in disease, these lipid droplets can be confronted, controlled, and removed. Science has identified the key players, and now strategies exist to restore balance, re-energize microglia, and protect the brain's health. So yes, fat might be the brain's new villain, but it's a villain with weaknesses. By targeting lipid accumulation and the enzymes that drive it, we can empower microglia to resume their role as tireless defenders, clearing plaques, regulating inflammation, and maintaining a clean, balanced neural environment. Alzheimer's may involve a cast of complex characters, but the story now includes a path toward resolution, where metabolic balance restores order and the brain's natural immune system can once again keep neurons healthy and memories intact. It's a tale of hope, resilience, and the remarkable ability of our own cells to recover when given the right support, a story in which the villain can be defeated and the hero, our microglia, gets its moment to shine.